Welcome to Excel Class Hub and welcome to class. My name is Man Elizabeth Queen, or Miss Elizabeth in short. So today I'll be taking you on chemistry and the topic Kinetic Theory of Matter, gas laws. Okay, so let's just go straight to matter. We all know that matter is anything that has mass and can occupy space. Matter is anything that has mass and occupies space. Matter comprises of particles atoms, molecules, or ions. Matter is anything that has mass and occupies space. Matter comprises of particles, atoms, molecules, and ions. So we have the general kinetic theory of matter, which postulates that kinetic theory of matter postulates that particles are in continuous rapid motion and possess energy. The kinetic theory of matter postulates that particles are in continuous rapid motion and possess energy. We have two states of matter, which is solid, liquid, and the gaseous state. So today I'll be showing the differences between the solid state, the liquid state, and the gaseous state, and I'll be saying the similarities between the three states of matter. First, we have the solid state. The particles of solid particles are closely packed. This is a sketch diagram to show that the particles of solid are closely packed. These are the particles of solids look like. They are closely packed. They have definite shape, definite volume, they cannot be compressed, and they are very dense. So let's go to solid. Liquid, I mean. The liquid state. These are the particles of a liquid state. They are not closely packed and they are not as loose as the gaseous state. So liquid state is just in between, not closely packed and not freely allowed to move about. And for the liquid state, they have a fixed volume, but not they have a fixed volume or size, but no definite shape. They will move to the gaseous states. So this is a sketch or a representation of the movement of gas molecules. Their collision are perfectly elastic and they collide with the walls of the container. So let's go to the differences between solid, liquid, and gaseous. Having established that we have three states of matter, so to differentiate between the theory, we have to put this in a tabular form. So we have solid, liquid, and gas. The first one is that solid, you have a fixed size or shape. Okay, let's just say fixed shape. They have a fixed shape. For liquid, no fixed shape. No fixed shape. For gas, no fixed shape. Number two, we have fixed volume, fixed volume, no fixed volume. The third one cannot be compressed, or you can use the word compressible. Cannot be compressed or incompressible, I mean. Cannot be compressed or incompressible. Compressed. Cannot be compressed. Can be compressed. The fourth one, very dense, less dense, and for gas molecules, they are least dense. So these are the four main differences between solid, liquid, and the gaseous states. So what are the similarities? Similarities or similarity. They all have a fixed mass. So let's move straight ahead to change of states. Change of states. Change of state is brought about by change in temperature. Let me write that down. Change of states is brought about by change in temperature. That is heating or cooling. So this will bring us back to the basics, our basic understanding on law of conservation of mass or matter. We state that matter can neither be created nor destroyed, but can be transformed from one form to another, or can be changed from one form to another. So that form brought about change of state. And what brought about the change of state is changing temperature. When a substance is heated, there's a change in the state of matter. For example, heating. Heating brings about melting, while cooling brings about freezing. Heating brings about melting, that is liquid from solid states, from solid to liquid. And in the case of freezing, from liquid to solid. Just like we cited instances on solid and liquid, so there are change of states too that involves the gaseous states, which we are going to dive into very soon. So before I dive into the different change of states, let's talk about boiling, evaporation and boiling. Evaporation and boiling. Evaporation, this is the process of vaporization of liquid at all temperature. While boiling, in the case of boiling, when a liquid is heated, the rate of evaporation increases, and the saturated pressure rises to a temperature at which the saturated pressure is equal to the prevailing atmospheric pressure. At that point, the liquid is said to be boiling, and thus we can call it our boiling point, the boiling point. So from the definition of the two terms, we can extract out differences between evaporation and boiling, which is this is the process of vaporization of liquid at all temperature. While boiling, when a liquid is heated, the rate of evaporation increases and the saturated pressure rises to a temperature at which the saturated pressure is equal to the prevailing atmospheric pressure. At that point, the liquid is said to be boiling, which is the boiling point. So what are the differences between boiling and evaporation? The differences are clear, which is in boiling, boiling occurs at a particular temperature, while evaporation occurs at all temperature. And that difference is that boiling involves all the liquid, involves or occurs all over the liquid, while evaporation occurs only at the surface of the liquid. Going further, still on change of, so like I said earlier, I said change of state occurs at the change in temperature. So when I said we have heating and cooling. Heating brings about melting, cooling brings about freezing and condensation. You can see melting and boiling. Melting and boiling. So now let's have a diagram to show the relationship between the change of states. So you have something like this: solid to liquid